Okay, so this is already done. Let's get to the good stuff, the back, right? So here we are. We already did some of the definitions. Let's hit them again, because you're going to need to hit them for your review guide, and we can just do two birds, one stone. Right? Great question. Expression inequality. I bet they will. So expression inequality. We're going to do popcorn like we did yesterday, but it's going to be better today because we learned something. Expression. Go ahead.
No equal sign.
No equal sign, right? An example of that might be saying like 2x or pi or 3x plus 1. They're all examples of expressions because they have no equal sign, right? They're just ideas. It's like blue kite, red ball, right? It's very mystical and poetic. Equations demand that we have a definitive answer, right? So they have an equal sign. Okay? Oh, my bad. So they have an equal sign.
It's not equation, it's equality.
Is that what it is? Either way. They're both the same.
It's equal equation.
So an equation has an equal sign. An equality has an equation as well, or equal sign as well. They're both the same thing. An example of that would be like 2x plus pi equals 3x plus 1. See how I did that? Right? That's an equation.
Wait, how's that?
You need examples, yeah. It doesn't say it on there, but it does for your study guide, so I figured we'll just knock that out now. If you don't have examples now, that's fine. Okay?
You just said that. Just said that.
Maybe if you were listening, not looking at the window.
Constant versus variable. Constants. Yeah, go ahead.
It's always the same.
Always the same. So it's a quantity, is how I would say if I'm being official. Yesterday I was trying to rush through it. A quantity that is always the same. So an example of that would be like 2, right? 2 is always 2, even when 2 isn't 2. Another example would be pi, right? Those are all constants. A variable. All right, Baker.
X or Y, like letters.
Yep, so examples would be like x, y, any of the symbols like lambda, right? Those are all variables. It's a quantity that changes, right? Right, it's variable. It depends, right? Again, if I tell you that x is 2 today, and on the quiz tomorrow you see x and you go, haha, I remember, x is 2, you're going to be screwed, right? Because guess what? X changes every day, right? All the time. It's variable. That's what variable means. It has variation, right? Arithmetic versus algebraic. Arithmetic, okay, for those of you not in the know. Did I tell you to answer that one yesterday? No, okay, good. Yeah, cross that out. I thought I told you not to answer that one.
Is properism manipulation the answer?
Oh, I wasn't listening.
Did I or did I not?
You never said it.
I might not have. You want to know what it is? It's short and sweet. Okay, we haven't talked about it in here. Again, I'm Frankensteining some of my old algebra stuff. I apologize for that. That should not be an excuse.
Wait, no.
Arith-
When did we get these?
Tuesday.
Arithmetic
Tuesday.
is numbers only. So everything you did, 5th grade and down, that's arithmetic, right? 5 plus 3, 5 divided by 3, 5 cubed, right? No matter what you do with numbers, that's arithmetic. Now, when you go beyond that into letters, that's algebraic, right? That's algebra. That's the difference.
Do we need those for the test?
Nope, not that one. Okay. I would assume that you guys know it in general, but yes. Yeah, Baker. You want to answer independent versus dependent?
Yeah.
All right, independent variable. Give it to me.
Not depend on another number.
Yep, she don't need no man, right? So independent variable is a variable that does not depend. Again, the key is does not depend on another variable.
Wait, which one is independent?
Yep, independent. Does not depend, right? That's independent, right? If you're independent, you don't depend on something. Now, dependent, Ethan, or not Ethan, Ethan, yes, Ethan. Sorry, I keep wanting to call you Evan because you look like a kid I taught once named Evan. Dependent. What's a dependent variable? It's a variable that what?
Depends.
It depends on another variable.
Do we need an example for independent and dependent?
No, you will not. Great question. Again, I'm trying to combine this with what your review guide looks like. It's the same thing with the question, slightly worded differently, and I'm more concerned about that. If you haven't picked up in here, homework, everything's made up and the points don't matter. It's just for your feedback. Because immediately after we grade it, what can you do? Correct it. Turn it in and correct it, right? Yeah, right? But the reason I have this done, right, is so that you take it home, mess with it, learn, and then come in with questions and get the instant feedback. Right? If we didn't do homework at all, you wouldn't get any feedback. Yeah.
Wait, so this is homework? From, oh my god.
Yes. Yes. Baker? Oh, you want to get the next one? Indirect versus directly proportional. What's indirectly proportional?
X and Y both increase and decrease.
Okay.
Like, you know.
Oh, like opposites. Yeah, I get what you're saying. Yeah. Calm down, Parker. Threw a desk at a kid. That's why we need the other camera in here. You never believe what happens. All right, so X goes up, Y goes down, Y goes up, or X goes down, Y goes up. Right, they have different in variation. I'll accept that. That's fine. That's shorthand. I know what you mean. And then directly proportional. That's when both go up or both go down, right?
So we don't need examples for those?
No, because what's going to happen is up here, you're going to do those examples. So what you're going to do is, let's call this one direct and this one indirect. Okay, maybe you called them differently, yes?
For indirect and direct, can we just put indirect as the opposite and direct as the same?
Give me the arrows, because I know they're the same, but how are they the same? You know what I mean?
Yeah.
Like both going up. Oh, okay. Not only are they the same, but they both go up, they both go down, right? I know what's going on here, right? Like you and I are the same, but like, how are we the same? You know what I mean? Like there's lots of different things that I could be talking about here. So be specific. Good question. Direct. So here's x-axis, here's the y-axis, right? So as x goes up, y is also going up. So x going up means to the right, right? So we're going to the right while we're going up. So draw an arrow that goes to the right and up. Does that make sense?
Yeah.
That's direct correlation. Direct, what do I call it here? Relation, right? Now, x here, y here. Indirect. Which one do you want to go down, the y or the x? Okay, so y literally goes down, and x is going to do the opposite, go up, right? And when we talk about up for x, we're talking to the right. So we're going down and to the right, aren't we? So this would be down and to the right.
Let's go.
Does that make sense?
Yeah.
Right, y is going down while x is going to the right. So it's pulling it to the right while it goes down. X is going to the right while y is going up, so it's pulling it to the right while it goes up. See what I'm saying?
Yeah.
Okay, so that's an example of an indirect relationship between x and y. What I want you to do is provide a real-world example. So this was not for the homework, okay? I'm trying to combine the two. Please forgive me. I know it's confusing. Label your axes. Give me a real-world scenario. As one goes up, the other goes up. What do you want to talk about?
A swing. Oh.
So as,
I know.
like, the force increases, so let's do force down here, then the height of the swing.
I didn't think that was.
So the force on the swing increases, the height of the swing increases, like a pendulum, I should say. What goes up while the other goes down?
Brakes.
Brakes?
What?
Yeah.
Like as you increase the brake force, the speed goes down. So as we increase the brakes, the speed of the car goes down, right? In theory. There you go. Now, I would like you to write like a little bit more than this so I know what you're talking about. If you just write brakes and speed and be like, what is he talking about? Okay? Or force and height.
Do we have to write like a story about
You know, just kind of explain it to me, okay? Label the things and explain, like force of the push, height of the swing, right? You see what I'm saying? Now I'll be like, oh, okay, I smell what you're stepping in. That's for the test tomorrow, okay? So these definitions, I won't quiz you on all of them because I don't need. If you know what a constant is, I bet you know what a variable is then too, right? See how I can get two for the price of one. Let's get the review guide out. Here it is. Yeah, turn it in. If you like your grade, and your grade is, let's make these out of what? Let's make each one 1 point each. So 1, 2, 3, 4, 5, 6, 7, 8 out of 8.
200 points.
I mean, when I plug it in the grade book, I do it out of 10. So it honestly does not matter. You know what I mean? Like, oh, you got an 8 out of 10. That's an 80%. So I put it in as 8.
Do we need to turn in the warm-up?
Yeah, warm-ups, turn them in. Tomorrow, remember you got to do your reflection. The reflection is live if you want to do it now. Oh, my head.
Was there a warm-up for Wednesday?
No, there was not, because Wednesday we did the test.
Wait, you turned that in?
Oh, we need.
The warm-ups, you can always turn in your warm-ups right after we get done on Wednesday. You don't get any warm-ups after that. No. Only do warm-ups Monday through Wednesday.
So,
Thursdays are review days. Fridays are
wait, we
quiz.
didn't do one yesterday.
Right, but Wednesdays, yesterday was taken up by test.
So do we just put like test in it? Like,
Yeah, that's fine. I mean, I don't know. I'm grading, right?
Alright, yeah.
I was there. And I know you're disappointed because warm-ups are like the best part of math.
Yeah, it's pretty cool, pretty cool.
Yeah,
You learn some new stuff.
Yeah.
You gave me two, and I don't think no one.
I'm sorry, Jace.
I don't think anyone did.
Yeah, I didn't
Yeah.
need you to.
What am I supposed to have?
You could have page 1 through 9.
Oh, wait, I need that.
Yeah, I
What am I
didn't
doing?
She thick, but she doesn't have a lot of problems.
Wait, we need to turn in the warm-ups?
Only 27 problems. And not all, it's all optional, right? It's not homework.
These ones?
Yes, turn in your warm-ups. Guys, every Wednesday, that's the last day we do warm-ups, right? So whether we did one or not, you can put it in the bin. Worst case scenario, I say, guys, I messed up. We're actually going to do a warm-up Thursday. And what do? You go to the bin and grab it, right?
What's up with this?
I don't know. It was left in here. It's not homework.
Are you sure?
It's not for a grade. All right, freshmen, calm down. Man,
Freshmen are slow.
they just aren't really. Okay, so everybody sit down. Let me explain the packet before you freak out. Every year is the same. Oh my God, there's so many problems. Oh no, and it's because you're conditioned that when you're assigned stuff, you have to complete it all, right? I get that. That's just not how things work in the real world.
Is this homework?
No, sit down and be quiet so I can explain it all at once instead of multiple times.
Give me some skin.
Oh man. Freshman. And you guys.
I should go out and run. You go crazy.
Alright, stapling is hard.
So when I see it takes the staple for a while.
Yeah.
Oh, I should probably go stick.
Wait, what are these?
We are not going to be able to answer all these. We're going to do as much as we can today.
Real numbers.
As much as we can fit in.
I
Okay?
got a question. What's this from?
That's from
A long time ago.
yeah, like the first week.
Yeah. I don't have time for it. It's late now. It's a 0. But
Is
it's
it zero unless I
yeah.
turn it in?
It's a 0 unless you turn it in by Friday, in which it is due, and that was like 3 weeks ago, so it's a 0.
I thought it's good until the.
Nope.
That's
That's not
only
how it works.
10.
No, that's tests and quizzes. Sorry. You're not gonna grade stuff later. It's homework. It's literally free points. Sit down. All right, here we go. You made your point. It wasn't funny the first time. That's the thing. Like if you make a joke and it fails, it's like you gotta move on to something else, dude. Okay. All right. So we're not gonna have time to do all this, which is fine because it's not due for a grade. This is a review packet. Thus it says review, right? It's not for a grade. It never is, which kind of sucks, but it's also kind of good. Would I encourage you to do it all? Yeah, because when you bomb this tomorrow, if you do, you need to get a head start on this, right? Because that's part of the thing you need to do for the retake. If you get lower than 65. We're not gonna have time to do it all. Okay? What I'm gonna do is I'm gonna go through and pick the ones that I think that you guys would want to see the most. If there's one you really want to see that I'm not doing, tell me. I think we can skip the chart. Do you agree or disagree?
Yeah.
Okay. Know your sets of numbers. Okay? Natural numbers are the counting numbers, the ones you count sheep with. Whole numbers are the natural numbers plus 0. Integers are the flips. So natural numbers, but also the negative signs, right? Irrational numbers are the weird ones, right? Those are the ones that are like fractions or decimals, right? But irrational ones are the ones that go on forever with no pattern, right? So things like root 2, even when it's divided by 2, like that last one, going to be irrational.
And-
Is 0.219 repeating going to be irrational or rational?
Irrational.
Rational because it repeats. It has a pattern. Okay. Just because it has a negative doesn't mean that it's automatically just an integer. Like negative 0.9991, that's not an integer because it's not a counting number and it's flipped, right? It's negative, well, great, but it's a rational number, not an integer. Integers are the counting numbers and they're flips. So like 1 and negative 1, 2 and negative 2, 3 and negative 3, not negative 0.9991. Root 4 is tricky because it looks like it should be irrational because it has a root, but it's not. What is root 4? 2. Yep. All right. Simplifying the expressions, I'm going to skip these as well. Hopefully you know them. 12. Explain what negative exponents do and the difference between negative a to the n and negative a to the n. One has a quantity, one does not. What happens when it is negative? What happens when it's positive? So it's a little bit further than your first quiz, right? We go a little bit beyond the question. So first of all, what happens when you flip exponents?
Wait, you're going straight to 12?
I'm going straight to 12. What happens when you, sorry, let me speak more clearly. I've got a headache and my mouth is very dry. What explains, we're going to get this. Explain what negative exponents do. Somebody. What does a negative exponent do? Yeah.
They flip.
Flips. What's the word that starts with an R? That, reciprocal. So it reciprocates. Either way works. Flip is the colloquial term, right? It's what we say in common speak. I love how the word common speak is colloquial, which no one knows what that means. It's ironic. It's like ambiguous. No one knows what it means, which is what ambiguous means. And the difference between these two. So when n is positive for this guy, right? Sorry. Did I say what happens when n is negative?
You said when n is positive.
N is even. Cross out negative. I did this at 8 o'clock last night, guys. I'm sorry. Even, odd. So what happens when n is even? What happens when n is odd? So check it out. If that's an even number up here, is this going to be a positive or negative answer?
Negative. No, positive.
What?
Positive. So think of an even number, like 2, right?
2 times 2.
If I had negative a quantity squared, would that come out even or positive? Or even or... Would that come out negative or positive?
Slow.
I'm worried you guys aren't going to get through this and you're going to be awful tomorrow at this test because we've wasted so much time already. Negative a quantity squared, right? That's an even number for n. Is that going to be a positive or negative answer? Shh. Hang in there, bud.
Positive.
Hang in there. Gentlemen, enough. It's going to be positive, right? Now, when negative a quantity to an odd number, like, I don't know, cubed, is that going to be even or is it going to be positive or negative?
Wait. Oh.
So if n is odd, it's going to be negative, right? Because we have a negative times a negative, that's even, times a negative again, that's positive. You smell what I'm stepping in?
Yeah.
Let me walk you through that. When n is even, we have a negative times a negative. What's a negative times a negative? Positive, right? If I have 4, well, it's a negative times a negative, that's a positive, times another positive. It's positive, right? Do you see how even numbers produce positives? Odd numbers, on the other hand, like 3, negative times a negative is a positive, but that last one, negative again, makes it negative. Okay? If I do that for the number 5, it's the same thing. Right now I'm negative, right? Now I'm positive. Now I'm negative. Oh, sorry. Questions on that? Okay. Combining like terms.
Is that, which one?
13. I'm going to skip 13. Do you agree?
Sure.
Yeah.
Simplify the expression. We're not skipping these.
Why not?
Why?
Yes.
These are
Since
easy.
we're not going through all of them, could you post the answers on Google Classroom?
My goal is before I leave for DeKalb today, which will be very soon after school, is to have a video where I'm not bogged down by you guys and I can go lightning speed through this entire thing. Just me talking and writing, okay? And then you can watch it. I may or may not pull that off. I'm going to prioritize you guys first because I only have one algebra class. Everybody else can watch multiple live streams that I did today, right? And that's the goal. I'm going to try to get that done. Baker, yes?
Did I turn in my review with my test?
I think so. All right. So first thing I do when I get a problem like this is I change these stupid division signs into division bars. So whatever this is divided by that. So it's going to be negative 5 plus 5 in the quantity all over 5 times 2. Now notice I didn't put the minus 1 down there with it. Why? Because now that's a separate term. Right? We have a separation for the first time by addition or subtraction. So that's going to be minus 1 division bar over everything in the parentheses. That parentheses, even though there's a minus sign there, says all of that's going underneath the bar. So 2 minus 3 over 3 is what I'm going to write that as. I'm going to break that down again. All of the stuff here, because it's in parentheses, over that stuff. The minus 1 doesn't go down here because it's a separate term. All of this was one idea. We had idea here, division sign, so still the same term, idea here, right? All one idea. Then we had a minus 1 divided by everything down here. 3 over 3 is 3 over 3. Yes?
Do we do that every time we see a different one?
That's what I would do. Okay? You just got to be careful because don't include the minus 1 down here. That's a separate term. Somewhere else, okay? So now we have negative 5 plus 5, that's negative 10. And then we have 5 times 2 is 10. Minus 1, what's 2 minus 3 thirds?
1.
1.
It's 1, because 3 thirds is 1, 2 minus 1 is 1. So we have negative 10 divided by 10, negative 1, minus 1 divided by 1, 1, negative 2. That's what I do with division bars.
Of course.
Okay? it can still be dangerous, like I pointed out. You got to separate the terms. You got to know when it's not under there anymore, right? But that's the idea. 15. Check this out. First thing that's weird, it's this whole thing squared, right? That's okay. We work from the inside out. We have negative 3 squared. Is that going to be positive or negative 9?
Positive. No.
Negative, because it's 3 squared first, right? Exponents come first, and then multiply it by negative 1.
I thought PEMDAS was a lie.
PEMDAS is a lie. This is true. But exponents always come before multiplication. That's just true, right? 3 squared happens first, and then we put a negative. So that's negative 9. Minus 9. Now, negative 3 says, see how it's in parentheses? That negative comes first now, because it's in parentheses, right? So make 3 negative. Did it?
9.
Square it, we get 9. Next one, 3 squared, that's easy, 9. So if you'll notice, we have 2 negative 9s and 2 positive 9s. What's that going to sum to? 0. Now, we're not done, because I want to show you how to do this portion over here. You could just call it a day and be like, oh, it's 0, it has to be, right? But I'm going to show you how to do it, okay? This part over here, 2 times 3 is 6, plus 5, minus 6 times 2 to the negative first. What do negative exponents do? They flip it, so it's not times 2, it's actually times a half. Right? That's what negative first power means, it just flip it. You don't have to square it or anything later. It's negative first. So we have 6 plus 5, well that's going to be 11. What's negative 6 times a half? Half of negative 6? Negative 3, right? So I've got to square it when we're done. So we have 0 times 11 minus 3, which is 8, squared. So we have 0 times 64, which of course is still 0.
Question.
Yeah.
If there's a line this on the place, we have to do that second part.
No, if there's a 0 there and it's a 0 product, then just write 0, you're good. I don't think that's going to happen though. That's why I wanted to show you this crap. Okay? I was nice on the quiz, not the test. All right. This guy. Solve for each variable. You've seen this before. We've done this. Do you feel like we can skip this for now and come back?
Which one?
16? Can we skip it for now and come back? Okay. This is a good chunk of the quiz. 18 and 19 are scary too. We'll come back. How do you feel about this stuff?
Easy.
Pretty easy.
Not too shabby.
Skip it, come back maybe? Same thing here?
Not too shabby.
And then we did this, yeah?
Easy.
Okay, I'm just wanting to make sure we get through everything. How about this guy?
Wait, which one?
25.
You skipped this one?
Yeah.
Because we did it for the homework basically.
25.
Only thing funny than 24.
We did it for the warm-up. Is that like what that is?
Yes, also this 25 is not a question, it's just stating something, so that's actually
45's like the bar with the person going up the slide, right?
kind of, yeah. So here's the deal. What it says is what's the domain of this relation? So domain has to deal with which values, x or y?
Wait.
X.
Wait a second.
What?
Wait, so wouldn't it just be like 0?
Why'd you cross off the 25 and make that?
Notice that 25 isn't actually a question, it just automatically numbered it. Sorry. I mean, it doesn't matter. It really doesn't. So D, the domain, is going to be x values, right? Now, what set of numbers does x exist in? Look at x right here. That's this line right here. What values of x show up?
0 through 10.
0 through 10, just the counting numbers? Or any number in between? Any number in between, right? Here's 3.14, right? That shows up. So x is any real number that is between 0 and 10. Inclusive. You see what I'm saying? 0 and 10 are included.
That's the domain, right?
Yeah, that's domain,
R
right?
with an extra line.
Yeah, R with an extra line. That's the thick R, right, for real numbers. Now, what if this was dots instead of a solid line? Well, then we'd have natural numbers, right? Only 1 shows up, 2 shows up, 3 shows up, something like that, right? And again, inclusive because it includes 0 and 10. You dig?
Yeah.
Okay. No?
Yeah, sure.
Okay. Range, on the other hand, let me use a better pen. Range, on the other hand, is going to be the y values, right? So y, some set, and then some restriction. Now, if you look at the y value, we only go up to about 3 feet, right? Something like that. My graph is a little gross. So it's going to be that y is between 0 and 3, right? Inclusive or non-inclusive?
No.
Why? Either way, which one are you saying, and then why? The second one. So inclusive. Why is it inclusive?
Because it's not the dotted line.
Yeah, it includes 0 and includes 3, right? It goes up to and including 3. It goes down to and including 0. So that's inclusive. Now the question is, what set does that belong to? Well, it's any number between 0 and 3, right? Even the weird numbers. So that's the real numbers. I know it's weird having like 3 and 2.5 feet and all that, but like think of them as 3 and 2.5.
And that thing right there's the T, or like a T, like in between Y and R, it's like a T or something.
It's a line to divide it up, yeah.
No.
No,
left.
the little E look
Oh, that's an E.
Oh, it's an E.
Yeah,
Where did you get T? Is that a thing that looks like an F?
like that.
I don't know.
It's okay.
What's that supposed to mean?
I think he was thinking curved T like that.
Of course.
How's that mean?
What does that mean?
Equal.
Like, how does it mean? Does it mean equal?
That E means exists in. So Y exists in the real number set. So any number that's a real number, Y could be. However, it has to be a real number between 0 and 3. You see what I'm saying? It's that set symbol we talked about at the beginning of the year. And then it says, is the relation a function and is it discrete or continuous? So first of all, discrete or continuous?
Discrete.
Continuous.
All right, we have differing opinions. Why is it discrete?
It isn't.
Why isn't it discrete then?
Because there's no dots.
Yeah, exactly. It's all connected, right? So it's continuous. Will you see a discrete function tomorrow? Oh, you bet.
Oh, yeah.
Yay.
There's a good chance of that. Continuous. Is it a function or is it not? Does it pass the vertical line test?
Of course.
Remember that? Yeah, so it's a function. We don't have any numbers down here. Like 2 doesn't get you 0 and gets you like 7, right? It just gets you 0. 4 gets you whatever that number is, 0, right? 5 gets you 0. 6 gets you 0. 4.5 gets you 3, right? But there's only one answer for each, right? It's not you put in $1 and out pops some random amount of change. You know what you're going to get. That's a function. Independent and dependent variable. Independent, time, right? Dependent, height off the ground. Right? Time, in this case, is the driving factor. You tell me the time and I'll tell you how high he is off the ground in that video we're watching, right? Okay. This page, vertical line test.
Fail.
Is 27 a function or is it not? Yes, it is. It passes the vertical line test. It only hits it once. Does this pass?
No.
Draw a line and show me where and then say no. Does this pass the vertical line
Wait,
test?
What do you mean? Oh.
Third one does, yep. What about the fourth one?
No.
It looks like it might not, but it actually do, guys. It passes. Yep, that's a function.
Which test?
The vertical line test, it's where you draw a vertical line, right? It only hits it at one point. It's curvy, but it only hits it at one point. What about this one?
Yes.
Yep,
No.
it does pass. If you try drawing lines, I'm going to draw lines right now. Only hits it at one spot.
All these lines are confusing.
Only hits it at one spot. Only hits it at one spot. Only hits it at one spot, right? Circle, definitely not. That's not a function.
Never.
But what if it is? That actually, we do ask that sometimes in math, but what if it was? And then we develop a whole field of mathematics out of it. Let him in. Can you let him in, please, one of you guys?
Did you say a circle can be tied to a square?
Any, yeah. Well, not necessarily a square, but a rectangle. Square's a little too specific. I'll show you one day. It'll blow your mind. Thanks, buddy.
Thank you.
Caden, need a review guide for you.
Just shut it.
It's
Shut that
not
hole.
back there.
You can go and sit down.
All right. So now let's go back to 16 and 17. Not homework.
16 and 17?
Yep.
Ethan beat Yeah, Ethan.
Alrighty.
All right, let's get P first.
You know what?
All right, we're getting P first. Pay attention. Okay. What I would do is I would screenshot this when I'm done. Don't try writing it as I go because I'm going to go too fast. And watch the magic happen. Make sure you're understanding what I'm doing. And if you don't, raise your hand. Yeah.
Can I get my math stuff?
You don't need it. Just use this. Stay here for now. Okay. All right. Turn in your math stuff tomorrow because tomorrow's Friday anyway.
Back to 16.
Yeah, we're going back to 16. So here's what I'm going to do. First thing, I'm going to get P on its own because P's already on its own as a term, right? X and Y are looped together. So what I'm going to do is I'm going to move this whole term over, and that's going to give me this. I moved it by subtraction, right? That's how we move terms. Again, I would encourage you not to write this down. I encourage you to screenshot it after I'm done and watch the magic. I know you are, and everybody does this, and they think they know what they're doing. They think it's what's best for them. And then every time, they get confused. And what happens? They come in and see me, and in 5 seconds, I explain what's going on. Because when you're up there on the board with me, doing one-on-one time, you're not writing crap down, and you get it
It gives you a self-revolve.
in 5 seconds. But you can get this from a screenshot. Divide by 4. Everything divided by 4. The 2 divided by 4 is a half, but it's going to be negative. 2 negatives, right? That's going to be a positive. X, y is already being divided by 3. If we divide it by 4, it's really like dividing it by 12. I'm not going to show you the other ways to do it, okay? That's how I did it. Next, let's get x on its own. So I'm going to start from, I'm going to move the 4p over, right? And leave xy over 3 alone. So now we have a positive 4p over here. Then I get rid of division by multiplying by 3. Everything gets multiplied by 3. The 2 and the 4p. So we get a 6 and a 12. Then we divide by either x or y, depending on which one you want to get. Let's divide by y to get x on its own. Done. Now from there, I can go get y pretty easily, can't I? Assuming we didn't screw it up. Just divide by x. Smell what I'm stepping in? All right. Cool. Moving on to 17. Yep, I got you. So, first thing I'm going to do is I'm going to get p on its own because it's in the top. I'm going to move over the xy. How am I going to do that? Multiply. Multiply everything. Now, when I do that, I do it in parentheses. So I have 3 times the quantity of x plus y because that's 2 terms, right, that I'm multiplying by, equals 4p. Divide by 4, we get p on its own. Could you distribute the 3? Knock yourself out. Next. Now I'm going to get x on its own. So I'm going to start from here. I'm going to divide by 3. And I'm going to get this.
Wait, what?
I'm starting from here.
Oh, you're starting from there. Okay.
Right?
He called me dumb.
Don't do that. Divide by 3. We're here. Now I don't need the parentheses anymore, right? Because it's all just one thing. That's all that's over there. So it's really just x plus y. So now I just subtract if I want to move stuff. I'm going to subtract the y, and I get x equals 4p over 3 minus y. Is it weird to you that I had the parentheses there? Is that weird?
Of course.
Okay. Other way I can subtract x. That's x, that's y. Makes it look easy, right?
Next.
Moving on. Again, do you see it is what I want to know. I like that you guys are watching. I think this is good. If only I made you notes where you didn't have to copy down your own notes in class and you could just watch the... Oh, wait, never mind. Next one. 18. Get p on its own. So I'm going to move everything except the 2p. So 2p stays.
Shut up, kid.
All right, check it out. Everything I'm moving except the 2p. So I'm going to move the 3. I'm going to move that. When I move the 3, it combines with the negative 5 to make negative 8 because I subtracted it. I'm going to subtract the 2/3 xy. I did it all in one fell swoop. Okay? So here we are. Now we're going to divide by 2. P is going to be everything divided by 2. Negative 8 divided by 2. Negative 4. I have 2/3 divided by 2. Well, now I have 1/3, right? But it's negative.
How's it 1?
Well, if I have 2/3 and I divide it in half, how many thirds do I have? 1/3.
Wait.
2/3. It's like having 2 chickens. I divide it in half, I have 1 chicken now.
No.
Right. Just a different way to think about fractions. So that's P. Chicken probably isn't a good example.
Like pie, maybe? There you go.
Yeah, maybe. All right, so now I'm going to get x on its own. So I'm going to start again from the beginning. Let me write that down so you're not lost. Starting from the beginning. Everything must go except the terms that have x and y in it. So the 3's got to go, the 2p's got to go. And I move those by subtraction, yeah? When I subtract 3, I get negative 8 and negative 2p. Now, I'm going to multiply by the reciprocal. What's the reciprocal of 2/3? 3 halves, right? 3 over 2? So 3 over 2. That means I am multiplying by 3 and dividing by 2. Can we do that all at the same time? Let's divide by 2 first. Everything divided by 2, what's that? That's going to be a negative 4. Now times it by 3. Negative 12. Divided by 2. Negative 1 times 3. Negative 3p. Do you see how I did that? I multiplied everything by 3. Or I'm sorry, divided everything by 2. And then I multiplied it by 3. All in one go. You can do it individually. Now I divide by either x or y, depending on what I want to get on its own. I'm going to divide by y. This time I'm going to divide by x. How we feel?
Fine.
Okay. Feeling better? 19. We're almost out of time, guys. Let's do this last one. First, let's get p on its own. Everything except p has to go. That means I get this. Over here, guys. Over here. I moved over the 1 by subtraction, you dig? And to get p on its own, I divide everything by -5. Now, this is not acceptable tomorrow. I don't want to see fractions of fractions. So let's divide everything by -5. 1 divided by 2, now divided by -5. That's the same thing as dividing it by 10, just -10, right? You smell what I'm stepping in here? 2 in the -5. Here, I have 5 divided by 3 divided by -5. Well, can't I do 5 divided by -5 first? That's -1. Now divide -1 by 3. -3rd. Or you could have done 5 over -15 and then reduced, right?
Wait, how'd you get?
5 divided by 5 is 1. It's negative, right? 1 divided by 3 is -3rd. And then we have -1 divided by -5. First of all, is it positive or negative? The answer. It's going to be positive, right? So it's a 5th. That's p. Next, let's get y on its own. I'm going to move over everything except the 5/3 y. How do I move that half x squared? How do I move it? How do I move half x squared? I subtract it, right? Because it's positive. I'm moving it by the whole thing over. Move that whole thing over by subtracting. All right, so what I did was I subtracted a half x squared to move it, right? It's a whole term, so I just, okay? Multiply by 3/5, the reciprocal, right? Now, if we're multiplying by 3/5, that means we're multiplying by 3, and we're dividing by 5, right? You dig? So let's divide everything by 5 first. -1p, 1/5. Here, let's just do this.
Parker, your shirt is inside out.
Divide by 5.
I think the 1/3
So check it out. I did it step by step. Instead of multiplying by 3 and dividing by 5, I just divided by 5. Okay? Now I'm going to multiply by 3. I could have done it all at once, but I thought that was confusing last time for you guys. I think having that third there might be more confusing. But that's what you would get. That's y. X. Where's my blue? Everything except the x squared term is going to get moved. So what I'm going to end up with is half x squared equals the stuff that was already there minus 5/3 y. Cool? 2 things I got to do now. Multiply by the reciprocal, which is 2. Everything gets multiplied by 2. That's the number one mistake I'm seeing is people not remembering to do it to every term. Whenever you divide or multiply, it gets everywhere, right? X squared becomes x when we root everything. All right, screenshot 19 if you want it. Make it quick. If you want to screenshot your own paper, go ahead. Yep, come on up. Stay up here. All right, there's 19. You ready for 18?
No.
Ready?
Yeah.
18.
Birthday spanking. Are you gonna get that from your mom?
Are we good?
Yeah.
All right. 16.
That's fine. Yeah.
When you're ready, tell me. Good? All right, 17. Try it at home on your own.
No.
That's my advice.
No.
Definitely the funniest thing that you've said today, Isaiah. Definitely the funniest thing. Whoa!
I dropped them.
I know. Oh no. Oh no.
Hey, can I get one?
Sorry, I'm just in one of those moods right now where it's just like everything hurts. All right. Question, comments, concerns?
Everything.
Right.
Promethean board.
All right, so that's that on that. Are there any more you want to see with the time that we have? I know we don't have much. Not all of this is going to be on your test tomorrow. Think about stuff that I could test together, right? For instance, I don't need to test this stuff individually because if you don't know how to do this, there's no way you're going to be able to do the condensing stuff. Remember that, where we needed to figure out the squares and all that? So individually, that's not going to be on there. But you need to know it because otherwise you're screwed for the later stuff, right? I do that all the time.
Like and subscribe.
That's right. Oh, man. No one is liking and subscribing because of this algebra class. They see me in here and they're like, he always has a headache at the end of the day. He's so cranky. Why is he so mean? You don't understand. You don't understand.
With that silver thing.
I need to tell you something. What?
With that silver thing that I don't know. What are you eating on now?